Does information have mass? If you want to know my answer, the short answer is no.
Greetings, this is Eugene the Philosopher, the greatest living philosopher after the unfortunate passing of Quentin Robert de Nameland, who has been the greatest living philosopher before me. In this video, I want to talk about at least one, maybe three papers by one named Melvin Vopson. These papers are really interesting, like some really original ideas are presented there. They raise some interesting questions, etc., etc., etc. So, without further ado, let's roll.
So we'll actually talk only about one paper. I'll only show you maybe a couple at the end that we'll talk about some other time, okay? I already plan to make another video specifically about information, the concept of information in physics, because reading those papers have made me think quite a lot, but still I only have the main point ready. I still need to think about some additional points to make the video longer, long story short. But anyway, the paper we're going to be dealing with today is this one, as I've said, by Melvin Vopson, the mass-energy information equivalence principle. I'll give you the link so you may read it on your own if you wish. It's free to read. So I propose to look into the PDF version because I hate the HTML one. Anyway, what does the paper talk about? Well, it talks about, basically it proposes this idea of mass energy information equivalence. Okay, we all heard about mass energy equivalence, which is accepted in relativity, okay, where E equals mc squared, roughly speaking. So here we add information to the pool, so to speak. And what is the logic? Like, how does author arrive at this thought? Well, he actually arrives at it with the help of so-called Landauer's principle. And what is it? It's a statement that in order to erase the one bit of information, like energy needs to be released, okay? And specifically, at the very least, this amount of energy. And the idea of Vopson here is simply like, okay, we can then sort of equate the information to energy through this formula, okay? And then we can equate, since we already have equivalence of energy and mass, we can therefore claim that information is not only equatable, so to speak, to energy through Landauer, but also to mass through E equals mc squared, okay? So this is kind of the logic. So here he introduces like the regular, informational thing, the entropy, blah, blah, blah. And then he says that since in order to erase some information, like let's say we have a sequence of bits recorded, right? And we want to erase it. So let's say our default state of our bits is 1. It could be 0, actually. It doesn't really matter. So we erase this information that we've had. We arrive at this state which carries no information. And since, according to Landauer's principle, some energy should be released, Vopson claims that it means this energy has been there in the initial state, right? Because according to the logic of the author, how else would it be not emitted, released, right? If it wasn't there in the initial state. And therefore, if it was there, the energy in the initial state, it means that information corresponds to energy. And therefore, it also corresponds to mass. And therefore, we arrive at this, roughly speaking, triangle, right? Where information is equivalent to some mass, and mass is equivalent to energy, and energy is equivalent to information, right? This is the logic of the author. However, and so basically the idea is if you have a data storage device and you record some information on it, it will become heavier. Its mass would increase. More specifically, like if you do the calculation, if you divide this expression by c squared to get the kilograms, right? You will arrive at a figure that at 300 Kelvin, that's roughly room temperature, 1 bit has this mass. 3 times 10 to the minus 38 kilograms, which is a very small mass, okay? Yeah. So it's much smaller than the mass of the electron, for example, which is what? 9.1 times 10 to the minus 31st. So this would be like 10 million times lighter than electron, I guess, or something to that effect. Okay, however, I seriously disagree with the author, and let me try to explain why I disagree with the author. So let's just start with this erase procedure, right? So Landauer's principle, and by the way, people are criticizing Landauer's principle. You may read it on Wiki even, you may read it somewhere else. But yeah, it's not like this is something set in stone. Actually, the author mentions this somewhere. Or maybe it was some other paper where he did this. Well, he basically says that Landauer's principle is pretty much universally accepted, which is not correct, okay? I cannot find it here. Yeah, Landauer's principle has been the matter of some controversy. Yes, it has been. But anyway, even if we accept that this is correct, I am actually kind of fine with this, okay? It looks suspicious, but for the sake of my argument, it doesn't matter. So my argument would be that this releasing of energy during the erasure, like where is the source of energy, basically? Because this is the main argument of the author, right? That the source of energy was information itself. Well, my argument would be that the source of energy would be whoever is doing the erasure, right? The machine that does the erasing. That's where the energy comes from, and that's why this heat is being dispersed during this procedure, okay? Because, let's take a fundamental look at this situation. Like, if we genuinely assume that the simple fact, like nothing physical, but the simple fact that the information was there, corresponded to some energy and equivalently to some mass, like, how do you think would the universe distinguish between this state and this state? Okay, because metaphorically speaking, you know, the universe has to attribute to this state a higher mass than this one, purely because this one has information and this one doesn't, okay, according to us. And how would the universe know, in quotation marks, that this state has information and this one doesn't? I don't think it has any way of doing this, you know, because you may have noticed, and spoiler alert, this will be the topic of my next video on information specifically, right? We'll talk about more philosophical stuff, like here we're talking about more technical stuff. Anyway, the universe, information is subjective, right? It's a matter of convention. Actually, he says that this sequence of bits, I think, encodes the letter I, if I'm not mistaken. Somewhere here he talks about this. Well, it doesn't matter. You may read it yourself if you wish. So how would the universe know that this state has information for us and this one doesn't? Because it's our convention that we agreed that this sequence will decode the letter I, right? We may have agreed that this sequence would decode the letter I. Right? We can't just introduce this convention. And therefore this will have information and this wouldn't, because it doesn't encode letter I. Maybe it encodes nothing, okay, in our new convention. You see, the information is subjective. It's a matter of convention. It's a matter of interpretation, if you wish. Therefore, I claim, this is my big claim, information is not physical to begin with. Therefore, information cannot be equated to energy, which is physical, and cannot be equated to mass, which also is physical, okay? So this is my big problem with this sort of approach, and basically my refutation of it, if you wish, right? The universe simply has no way of distinguishing between this state, and therefore it cannot, again, sort of metaphorically speaking, attribute extra mass to this state and not to this one, you know? It just makes no sense, right? Unless you think that the way you interpret the world, the things that you consider that are information, which is kind of arbitrary, to be honest, right? Culturally informed at the very least, that it somehow touches the universe at the very foundation. Like, it's just wrong. It's kind of insane, actually, to think about, to think in this way. So, yeah, this is wrong. The argument is wrong. The energy that is being released during the erasure, according to Landauer's principle, even if we agree that it is correct, does not come from intrinsic energy of the information itself. It comes from the erasure procedure, which is undertaken with the use of some external machinery, right? It's something else that's doing the erasure, and this something else is what provides the energy that is being released in this process. So long story short, this is my logic, this is my argument against the idea of Vopson. Yeah, and actually, like, just one funny tidbit, somewhere at the end, he actually proposes that this information, this extra mass from information, I mean supposed extra mass from information, is what could be a candidate for dark matter, which is kind of funny. You probably know my opinion on dark matter. I propose to fix our dynamical laws, for example, with the help of Mach's principle. See one of my recent videos about Mach's principle. I think it's called The Best Theory of Gravity or something like this, and inertia. Well, a relatively recent one anyway. Okay, so this is pretty much this paper covered. Again, there are a couple of others which I want to talk about, and I'll probably use them as a stepping stone for a discussion of this sort of reification of information in modern day physics, which I kind of hate, honestly. But no offense to Vopson, I mean, it's good that people are thinking about this stuff, and himself included, so... But unfortunately, I think, like, he arrives at very, very suspicious at best results, okay? And in my eyes, this is just plainly wrong for very simple fundamental reasons, okay? Like, once again, how would the universe know that this state, according to us, has information and this doesn't, right? It's a convention. We just agree, you know, that this has information and this doesn't, but should nature care about our agreements between each other? I don't think so, right? Information is not physical to begin with. Yeah. Therefore, there could be no equivalence between information and energy or mass, because they are physical. Yep. And by the way, we're kind of reaching the conclusion here. I think I already gave you the conclusion that essentially information cannot have mass, okay, because it's subjective, it's not physical. And believe it or not, Vopson is not the first. Like, this paper is from 2019, right? But in 2013 already, we've had this paper literally asking the same question: does information have mass? Long story short, I actually don't know what they arrived at. Usually the answer is no, they say, but somehow, if you read the text, like, sometimes they say as if it does, so I don't know. Our results indicate that there are different answers, basically, so there is no definitive answer. Well, I'm giving you a definitive answer, okay? It's no. But anyway, they're saying that depending on the physical situation, the answers could differ, and sometimes the mass can even be negative, which is kind of funny, right? And by the way, Vopson here proposes an experiment. Basically, he says, well, let's record a bunch of information and you know, check if the mass on some hard drive, let's say, and check if the mass has changed. Well, again, believe it or not, such experiments have been made, and they are described in this paper at the very least, okay, at least some of them. And long story short, it's not definitive, okay, what they get. And the biggest problem of them not being definitive is, well, first of all, it's a very small change that we expect to see, right? This one. And actually here they give some estimates as well, as you can see, using the very same formula, by the way. So not even the formula is original. Not even the idea is original by Vopson. What is original by Vopson is that he makes this leap of faith, so to speak, to introduce this equivalence, which I think, again, according to myself, is absolutely misinformed and simply wrong, okay? But anyway, at least it's an original idea, okay? I can tell you that. So anyway, basically the biggest problem is that the G constant is not known with enough precision to make these measurements, okay? You may remember that the G constant, like something like 0.1% error is currently there. Like, different measurements give you different readings, which again differ by like 0.1%, which is crazy inaccurate, right? Actually, here they say, yeah, 0.15 actually, right? Yep. So in order to measure this, it's unacceptable to have the G constant unknown, essentially, right? And again, all the problems with G constant we've discussed in the video about Mach's principle. Long story short, it may not even matter what G constant per se is, because it's just a scale factor, okay? But anyway, I digress. Yeah. So, does information have mass? If you want to know my answer, the short answer is no.
Thank you for watching. The eons are closing. If you wish to support me, please consider joining my Patreon. That is patreon.com/philosopher. See the link in the description. Or if you have a scientific theory of your own and you'd like my help in developing it, please join my alternative science coaching program, also available through Patreon.